Hey guys, Joe back once again with some OCR FSMQ lessons, and today we are talking about tangents and normals involving differentiation. So the learning objective today is to name the equation of tangents and normal to curves using the line equation and differentiation. So we're talking about things that we did last lesson as well as things we did many lessons ago. But let's get into things. These are classic questions on the OCR FSMQ. So the graph of y equals x squared plus 3x minus 9 is shown by this here. Name the tangent at the point 39. So at the point 39 we have about there, which is about right, I think. We've got a tangent going through it. Now remember, to name a line we need 2 points. We need two things. We need a gradient and the point on that line. So how do we find the gradient of a tangent at any point? Well, remember we use differentiation, so we do dy by dx, which is bring the power to the front, knock 1 off the power, so 2 to the front, so it becomes 2x, the 1 to the front becomes 3, and the constants disappear, so we get dy dx equals 2x plus 3 right there. And then we put our x coordinate through that we've been given to get the gradient at that point. So there you go. When x equals 3, the gradient equals 9, because 2 times 3 is 6, add another 3 is 9. So there's our gradient. And how do we name a line? Well, you can think about it, y equals mx plus c, but we don't have a y-intercept for that, so we're already stuck. But what's the other thing that we use to name a line? Well, we've got the point there. We use that equation there. Y minus b equals mx minus a. That was in a lesson a long time ago. Well, not a long time ago, probably a couple of weeks. But we know we'll have a known point. We have a gradient. We can use that equation. So put in the numbers. Y minus 9 equals 9x minus 3. Expand your bracket, so you get y minus 9 equals 9x minus 27, and just tidy it up a little bit and call it y equals 9x minus 18. So that is your first answer there. That'll be worth 2 or 3 marks in an exam, and it's nice and straightforward. Let's do another one. The graph of y equals x cubed minus 2x squared plus 3x minus 9 is shown. Name the tangent at the point x equals 1. So we need 2 things to name a line. We need the gradient and the point on that line. So we know that y equals x cubed minus 2x squared plus 3x minus 9. So if x equals 1, then y equals 1 cubed minus 2 times 1 squared, add 3 1s, minus 9. So y equals a minus 7. Therefore our point is 1 minus 7. You'll have to do that first. I mean, you can find your gradient first if you want to, but I like to find my point, so I've got my gradient and my point, and then I'm ready to go. But yeah, that is our point. If you're given an x equals 1, you put that back through the equation to get your y coordinate, and then stick them in a nice little coordinate. So to get the gradient, we find dy by dx, so power to the front, knock 1 off the power, so you get 3x squared minus 4x plus 3. Stick your x coordinate through, we're giving it as a 1, so you get a gradient of 2. And now how we'll name a line is y minus b equals mx minus a. So carefully your double negatives here, it's going to be y minus 7 equals 2x minus 1. So y plus 7 equals 2x minus 1. Expand. Y plus 7 equals 2x minus 2. Tidy up, and you get y equals 2x minus 9. And that is the equation of your tangent. There's another one. I'm just going to put that up there. I'm not going to talk you through it. Have a quick look over that. Pause the screen and see if you would have got the same answer. It's another one where x equals minus 2, so we have to put it back through the equation to get our y coordinate. Then we've got our point. We dy dx it, put the x coordinate through, get a gradient of 12. Y minus b equals mx minus a. Double negatives all over the shop there, expanding and tidying. It should be fairly straightforward. The other part of this lesson is normals. So The graph of y equals x squared plus 3x minus 9 is shown. Name the normal at the point 39. So, normals hit tangents at 90 degrees, and we'll talk about that in a second because that means it's perpendicular, which will bring back theory from, I think, lesson 3 or 4. A normal meets the tangent at 90 degrees, so their gradients have a relationship. Now, if anybody can remember this, shout it out now at the screen. It is, of course, well, we're not talking about that yet. To find the gradient, we do y dx, put x coordinate through, x coordinate in this case is 3. So we put with 3 through 2x plus 3, and you will get 9 again. But that's the gradient of the tangent. But remember, we want the normal, so it is the negative reciprocal that you do. So it's going to be negative a ninth, because perpendicular tangents are negative reciprocals of each other. So we roll it over and sign change. That's what we do. So we've got the point, we've got the gradient now, and it's back to that time again. Y minus b equals mx minus a. Y minus 9 equals minus a ninth x minus 3. There, I would just times throw it by 9 to get rid of that fraction, to get that. And that minus 1 in front of the bracket just means change everybody's sign in there. So you get that. And then you take the 81 over, and the x over, because I like my x's to be positive. So I take that over there. So 9y plus x is equal to 84. But, yeah, that's a normal for you. Let's do another one. Find the equation of the normal that at the point where x equals minus 1. So it's that one again. The examiner trying to trick us. But let's find the gradient first. Y by dx equals 6x squared minus 10x minus 8. When x equals minus 1, the gradient of the tangent is 8. But remember, we don't want the tangent, we want the normal. So we do the negative reciprocal of that, which is minus an eighth. We've got the point. I've just put minus 1 through and got 12. You would have done the exact same thing. Let's do it now. So you get 2 minus 1s, which is minus 2. Minus 5 1s, so it's going to be minus 7. Minus 8 minus 1, so it's going to be plus an 8, so it's going to be plus 1. And plus another 11 there, you get 12. So I was right. And y minus b equals mx minus a. Put in my numbers to get that. There I would times throw by 8 to get rid of the fraction, to get that. Now take the x over to join and become positive, and take the 96 over the other side, and you'd get that. And that is the equation of the normal. You can write this in any form you want. If you want y on its own, if you want x on its own, whatever. The examiner will give you the mark. It specifically says in the mark scheme, any form of the equation will be enough for the mark. So unless they say write it in the form y equals mx plus c, you would have to get y on its own. But I haven't seen those on FSMQ. It's more to do with A-level papers when they do that. But that is pretty much that for this lesson. I hope you guys have found it helpful. Please leave any comments down below if you need any help on it. More than happy to talk you through it. And the next lesson is the reverse of differentiation, which is integration. So that is where the PowerPoints start to become more original, more mine. Because, you know, when I did further maths at GCSE, we didn't cover integration. So, you know, I had to make my own kind of stuff. But, yeah, I hope you guys have found this useful. And leave a like if you did. Leave a dislike if you didn't, I guess. But, yeah, I shall see you guys for the next episode, which will be integration in a couple of days' time. See you guys then.